Hi everyone, welcome back once again. We are still continuing with our grade 12 November 2021 past paper revision. Today we're going to focus on question 3, which is our sequence and series. And today we're going to look at quadratic sequences. Question 3, consider the quadratic number pattern minus 145, minus 122, minus 101. 3.1 it says write down the value of term 4. Okay, write down the value of what? Of term 4. So we know that this is a quadratic sequence, meaning that we can first go and get the first difference, right? So how can we get the first difference? We say the next term subtraction the previous term. So it should be minus 122 minus, be very careful here, you can make a mistake with the sign when you are subtracting, right? So it's the next term, which is minus 122 minus into minus 145, right? So the minus is for the formula. Also when we come here to be minus 101 minus into minus 122. Okay, so just be very careful with the sign so that you cannot make any mistake there. All right, so here it will give me 23, right? So this first portion I'm getting 23, then the other portion is minus 101 minus into minus 122, and it's gonna give me 21. All right, 21. Then this is our what? Our first difference, right? So we need also, we know that in a quadratic sequence there's first difference and second difference. So the second difference, you see first difference, you subtract the first difference again, 21 minus 23, it's going to give us negative what? Negative 2. All right, so that is our second difference. Okay, second difference. Okay, so we can get term number 4 now. How can we get term number 4? By actually, we know that the second difference will always be the same, right? So it will remain negative 2 as we continue. So then we can say this 21 plus negative 2, right? So it's basically 21 minus 2 is going to give us what? 19. Okay, it's going to give us 19. Then to get term number 4, it will be equals to what? Minus 101 plus what? Plus 19. Okay, so minus 101 plus 19, it's going to give us what? Negative 82. That is our term number 4. That's basically how we do this. Okay, 3.2. Show that the general term of this number pattern is Tn equals to minus n squared plus 26 and minus 70. Alright, how can we show them this? So we go back to our sequence. We know that the second difference is equals to what? Is equals to 2a, right? So we can say, to solve for a, we'll say 2a is equals to second difference, which is minus 2. So to solve for a, we divide both sides by 2. A will be what? Minus 1. All right. So how can we solve for b? We know that 3a plus b is equals to term 2 minus term 1, which is 23, right? So 3, we have already calculated a is minus 1 plus b is equals to term 2 minus term 1, which is 23. Then b will be equals to 23. So it's negative 3 when we transpose to positive 3, then b is equals to what? 26. All right, how can we solve for c? We know that a plus b plus c is equals to term number 1, right? And term number 1 is equals to what? Minus 145. Okay, what is our a? Minus 1. What is our b? 26 plus c is equals to minus 145. Then this will be 25 plus c is equals to minus 145. C will be minus 145. When we transpose 25 to be minus 25, then C is gonna be equals to minus 170. All right, we can finally go and get our Tn. Tn is equals to an squared plus bn plus c. Then Tn will be equals to, what is our a? Is negative, so it will be negative n squared. What is our b? Is 26. 26, and our c is 1 minus 170. So that's our general formula. Okay. Let's now move to 3.3. It says, between which two terms of a quadratic number pattern will there be a difference of minus 121? Okay, so this is one of part of the quite challenging quadratic sequence questions, and we have already covered them in our session. If you check the video in the description down below, I've just put a link there for the session, right, where we covered 4 most challenging quadratic number pattern questions. Okay, just go and watch. It's very informative. It will help you. And this was one of the questions that were there. Okay, so it says, between which two terms, right, of the quadratic sequence will the difference be 121? Obviously, they're talking about the first difference, right? Will the first difference be 121? Okay, to answer this question, you can simplify it by saying, what if the question said between which two terms will the difference be 23? How would you solve that question? Between which two terms will the difference be 23? Okay, we can see that 23 is in position n equals to 1 on the first difference, right? On the sequence of the first difference, which we know it's an arithmetic, right? So a difference that is in position number 1, it's formed by which terms in the quadratic sequence? Is formed by term number 1 and what? And the following term, which is term number 2. Can you see? Okay, so meaning that if we just know the position of the difference, we can determine that it is formed by which term and which term, right? So check here. Let's check 21, right? It's in position n equals to 2 on the first difference, right? And we can deduce, oh, it's actually formed by term 2 and the next term, which is what? Term number 3. And it's true. It's formed by term number 2 and term number 3, right? So we can use that ideology to actually say, oh, actually, if we get the position of this difference of minus 121, we can actually deduce that, oh, it's actually formed by this term and actually the next term. Okay, so meaning that what we have to do now is to go and get the position of minus 121, right? Obviously, minus 121 is the difference, so it's found on an arithmetic sequence there. Okay, where the general formula is Tn equals to a plus what? N minus 1d. Okay, so in Tn, we're going to replace by minus 121 because we want to know its position. All right, what is our a? Remember, a, we are taking it on the first difference because we want to find position on first difference. A is 23 plus n. We are looking for n. What is the difference? Common difference here is what? Is negative 2 in this pattern, right? The common difference is negative 2. All right, so we're gonna solve for n by taking 23 to the other side. It will be negative 23 minus 121 minus 23. So let me quickly check that. It will be minus 144. We divide by negative 2, then we'll be left with n minus 1, right? We are dividing by this negative 2 there. All right, minus 144 divided by negative 2, it's gonna give me 72 is equals to n minus 1. N will be 72 plus 1, which will be equals to what? 73. Now we have found the position of this difference of minus 121. Then we can deduce that actually this difference is between term number what? Term 73 and the next term, and term 74. Okay, so we can answer the question, between which two terms of the quadratic pattern will there be a difference of minus 121, is between term 73 and term 74. All right. 3.4. What value must be added to each term in the number pattern so that the value of the maximum term in the new number pattern formed will be 1? All right. It's quite an interesting question, quite challenging, and we have already covered this in one of the master for challenging quadratic sequence question session, right? So please go and watch that video. It's very informative. We have something like this, but here it's just a little bit shifted, a little bit different, right? So they are saying in this sequence, obviously there's a maximum value, right? So now, what value now can we add in each of these term in the quadratic sequence so that we can change that maximum value and form a new one, which is what? Which is 1. Okay, so that's what they're basically saying. So first step is to know what is the maximum value of the sequence, right? What would be the maximum value of the sequence? Okay, take a look at the general formula that we got of the sequence. It's minus n squared plus 26 and minus 170. And this is the same as the general formula for a what? For a quadratic function. It's a parabola, right? Although we are doing sequence and series, we must use a relational conceptual understanding approach in order to relate this with function, right? It's a function. But now, what kind of function is this? It's a quadratic function, right? Where our a is negative, meaning that it's a sad face, right? So if it's a sad face, it's true that obviously it has a what? A maximum value. And we want to look for this maximum value, right? We know that the maximum value is at the turning point, meaning that you have to calculate the coordinates of the turning point. Can you see that now this knowledge of function can also be applicable in sequence and series? Very, very important. Okay, so quadratic sequence, the same as a quadratic function, right? And our a is negative, that's what we're saying, and this is a sad phase. Obviously there's a maximum value. We need to get that maximum value and check what value can we add so that we can change that maximum value to be 1. So that's basically what the question wants. All right, so how can we get the maximum value? X at turning point, right? X at turning point is equals to what? Is equals to minus b over what? Over 2a, right? So in this case, because x is replaced by n, we'll just say n at turning point, right? Is equals to minus b over 2a. So minus b, right? Minus b, our b is 26, so it will be minus 26 over 2, our a is negative 1. All right, so it will be minus 26 divided by minus 2, and our answer will be what? Will be 13, right? So the position where we have the maximum turning point is when n is equals to 13. It's term number 13 that will actually give us the maximum value of the sequence, right? So we've just calculated the position. Let's go and get this t13, because now we have our n where we have our maximum value, the position in which the maximum value is standing. It's when n is equals to 13. Okay, but we want the value of y, or rather the t13. So we're gonna go back on our formula and we replace n by what? By 13. Then we calculate this maximum value of the what? Of the sequence. All right, so the maximum value t13 is going to be equals to negative 1. So negative 1 is the what? Is the maximum value of the sequence. Okay, so this is the maximum value of the sequence. So let's go back to the question. What value must be added to each term in the number pattern so that the value of the maximum term in the new pattern formed will be 1, right? So basically you are going to your maximum value and check what value can we add here, right? So that the new maximum value that can be formed can be what? Can be 1, right? What can we add on t13? So we are saying t13 plus a certain x. We want to know what can we add, right? So we'll just let it to be x, so that our answer will be equals to what? 1, right? So the maximum value, okay, so let me just write it as the maximum value plus x is equals to 1. What can we add on the maximum value so that the new term will be 1? So the maximum value, we get it as minus 1 plus x is equals to 1. We can solve for x, right? So x will be equals to 1 plus 1, and x will be equals to what? Will be equals to 2. Okay, so now we know, so that we can get a new maximum value of 1, right? New maximum value of 1 on the previous one, or rather on the sequence, we must add 2 on each of the sequence there, so that we can change and form a new sequence that will give us a maximum value of what? Of 1. So that's basically how you answer this. Otherwise, great off. Thank you very much for joining. Make sure that you watch this other session that we had on quadratic sequence, on mastering 4 challenging questions, so that you can conceptualize this knowledge. Otherwise, that's all for me. Thank you very much for joining, and goodbye.